This call is now being recorded.
See, uh, am I audible?
Yes, sir.
Okay. So see, this is my instrument. Here I have my instrument, and this is my uh, main station. So when I have taken the reading here, it is showing. So I will take it as 1 meter. Okay, just for your giving brief idea. And here there is a one mountain or say undulations. This is B. This is C. This is D. E. Okay, this is at the station A. It is 1 meter. Here it is 3 meter. Here it is 7 meter. Here it is 9 meter. Here it is 6 meter. Okay. Now tell me what is the height difference between A and B? You can comment or you can unmute and you can tell me the answer. What is the height difference between 1 and 3 for A and B? That is 3 minus 1 is how much? 2 meter. Correct?
2 meter.
Okay. What is the height difference between B and C?
4 meter.
4 meter. Is 7 minus 3 which is equals to 4 meter. Correct? Now, what is the height difference between the C and D?
2 meter.
Now tell me what is the height difference between B and E? D and E. E is how much? 6 meter and B is 3 meter. Height difference between B and E.
3 meter.
Yeah, 6 minus 3 equals to 3 meter. Okay, now tell me what is the height difference between B and D? What is the height difference?
6 meter.
Is 9 minus 3 which is equals to 6 meter. Okay, this is what we will do in leveling. Okay, so if I clear everything, see, this is my building. Okay, so here I have kept my code light. Okay, this is my stuff. Stuff is nothing but a scale. Okay, what other scale what we use? It is like the same scale only. Okay, so here it is showing how much the level it is 100 meter. Okay, the height of the building is 3 meter. 3 meter. 3 meter. The height of the building is 3 meter. Therefore, this level will be how much? 103 meter because 100 plus 3. How much it is? 103. Now 103 plus 3 is how much it is? This level will be 106. This will be 109. This will be 112. This will be 115. And this will be 118. Okay. So this this also will we will use in the building work in some site work. See, it is like this. Okay. Here its level is say 100 meter. Okay, at this point I will call this one as a benchmark. I will explain each and everything. Okay, so when I kept my stuff here, okay, after doing all calculation I have got RL as means level, reduced level. We will call this one as a reduced level. RL equals to 100 meter. Okay, and this is how much this distance is. Say I will call 3 meter. This is 2 meter. Okay, now this level will be how much? 100 minus 3, that is 97 meter. Okay. Now this level will be how much? 97 minus 2, it is 95 meter. So what we say that the total depth, how much it is? The total depth is 2 plus 3, that is 5 meter depth. We have done excavation of how much meter? 5 meter depth. Okay. In terms of levels, you want to say means that is 100 minus 95, okay, is equal to 5 meter excavation we have done. Okay. While constructing the road, okay, starting it will be flat. Okay. Sometimes it will be like heap. Okay, like this. Okay. So when you are constructing the road, say it is 100 meter here, you should maintain 100 meter at every point. Okay? But at some position we can't maintain 100, 100. Okay, so there will be little bit rise and there will be fall. Okay, so it may be 100, 99, 100. Okay, and here it is 101, 102. Okay, again here 101, 100, 100, 100, 100. Okay, like this also. So I just have given a brief idea what is leveling. Here in leveling, nothing more is there. Only adding and subtraction is there. Okay. You should only remember that when I should add and when I should subtract it. Okay. The principle of leveling. The principle of leveling is to obtain horizontal line of sight. Okay, with respect to the vertical distance of the object above or below the line of sight. Okay, see, this is my horizontal axis. Okay, this is my vertical building. What I'm doing, I'm taking the horizontal sight. Okay, with respect to vertical building. Okay, this is the main principle of leveling. Next, object of leveling. The objective of leveling is to find the elevation. That only I have said that 100 meter is 20, 97 meter, 95 meter. These are the levels. Okay, to find the elevation of a given point with respect to some assumed reference line or called data. Okay, this 100 is there now benchmark. Literally, I have said that benchmark. This is our reference line or data. Okay, with respect to this one, we will say, okay, with respect to this line, we will say this level is how much meter below. Okay, and with respect to this one, how much is 5 meter below. Okay. Then the second point is to establish point at a required elevation with respect to datum. Okay, I'm explaining the second point. Okay, this is 100 meter. Okay, I want to uh, say, okay, I want to create a step. Okay, one small step, and its level should be how much? 1.150. Okay, 100.150. So what I will do with the help of auto level or dumpy level and with the help of this staff, okay, with the help of this staff or scale, I will construct the step, okay, one step, okay, and its level should be how much? 100.150, that is 150 mm height. Okay, if this is your step, this height is how much? 150 mm. This height how much it is? 150 mm. This height how much it is? 150 mm. Okay, so we can establish a new point. Okay, we can establish a new point with respect to elevation. Okay. Say the engineer will say construct uh, one another step. Okay, I will take this one. Another step uh, for an elevation of how much? 106.000. Okay. So what I will do with the help of the auto level and the scale, I will uh, try to adjust because shifting the instruments and etc. We will later we will see that one. And finally, I will reach for this level. Okay. Just remember, just remember that to find the elevation of a given point and to establish the new elevation point. Okay. With always it will be with respect to datum. Next terms used in elevation, sorry, in leveling, that is level surface, level line, horizontal plane, and horizontal line. Okay, what is level surface? It is a surface parallel to the main spheroidal shape of surface of the Earth. Okay, initially I have said that in geodetic surveying we will consider the actual shape of the Earth, and in plane surveying we will consider Earth as a flat. Okay, so here we are studying about the plane surveying. Okay, in next semester we have in advanced surveying we have geodetic survey. Okay, so presently we will focus on the plane surveying. In plane surveying, what we will consider Earth as a flat. Okay, so level surface is nothing but the parallel to the Earth. Level line, line lying on the level surface. Okay? Lying on the level surface. Okay? It can be your land or it can be your building. Okay, say this is a slab. Okay, this is also a leveled surface. Okay, you take a road. Okay, this is also a leveled surface. Next, horizontal plane to which a point is plane tangential to the level surface. Okay. Horizontal line, it is a straight line tangential to the level line. Okay. Here they have taken the actual shape of the Earth. Okay, this is our instrument. Okay. And here we can see this is our leveling rod. Instead of going for this one, you won't understand leveling shaft, benchmarks, etc. So first I will go to the instrument, then I will come back to this slide. Okay. Terms used in leveling: datum, mean sea level, and elevation or reduced level. Okay. So before understanding anything, this one is most important. That is MSL, mean sea level. Okay, this is most important. Just don't forget this one. So we will go one by one. That is datum. It is an arbitrary level surface from which elevation of points may be referred. Okay. Initially, I have said that this is a reference line. In India, mean sea level is considered as datum. Okay. Mean sea level is considered as a datum of zero elevation and it is situated at Karachi. Okay. Then what is mean sea level? Okay. It is the average height of sea. Okay. It is the average height of sea for all stage of tides. Okay. Just remember, for all stage of tides, it is derived by averaging the hourly tides over a period of 19 years. Okay. For this one, I have a pic. I will show you instead of showing it here. Then, what is elevation or a reduced level? It is the height or depth of any point above or below the datum. It is denoted by RN, that is reduced level. Okay. Here, this is your datum. Okay. The your elevation or RA, let me be on this line or above this line or below this line. Okay. Okay. Here you can see mean sea level. See, these are the tides. Okay. These are the tides, and they have studied it for 19 years, and they have fixed the mean sea level. Okay. Here you can see the datum line, okay, which is situated will be in the sea. Okay. So we will take this as a reference line. Okay. This black color one, what you see, we will take this one as a reference line. And, okay. Okay, important terms are there. Let's explain them too. So another one is benchmark, line of collimation, height of instrument, and backside. Okay, these are most two important things: foresight, backside, and intermediate side. In three are there. Foresight means seeing it forward. Intermediate side means if there are A, B, C, D. Okay. From A, I am seeing B. Okay, this will be the foresight. From A, if I see the C, it will be the intermediate side. Okay, and if I shift my instrument to D, okay, and if I take backside towards the C, means it will be backside, foresight, intermediate side, and backside. These are also most important. Benchmark. Okay, we have also have a different types of benchmark, that is temporary benchmarks and permanent benchmarks are there. So we will see one by one. Okay, what is benchmark? It is a fixed reference point. Okay, it is a fixed reference point of known elevation with respect to datum. Okay. This is my sea. Okay, this is my land. Okay. Initially, I have said that here I have taken 100. Okay. This is nothing but a benchmark with respect to, and mean sea level it will be 0.000. Okay, just remember the level of the uh, produce level for the datum or a mean sea level it will be 0. So with respect to this one, I have taken benchmark as how much? 100. So this is a benchmark. Line of culmination means it is a line joining the intersection of cross hair of a diaphragm to the optical center of the glass. Okay? And it is continuation. It is known as line of sight or line of culmination. Means in instrument it is there. Okay, this is your eyepiece. Here we have eye. Okay, and here we will have some diaphragms. Okay, from where we will see. Okay, height of the instrument. It is the elevation of line of culmination with respect to datum. In simple words, if I draw like this, okay, this is my datum line. Oh, sorry, surface level. Okay, and if I hold a stuff here, means if I hold a scale here, so line of culmination or line of sight. Okay, and in scale it is showing 3 centimeter. Okay. It is not 3 centimeter, just for your understanding I am saying that. Okay, this is your instrument and this is your scale. Okay, so this height, okay, it is how much? 3 centimeter is nothing but your height of the instrument. Okay, next one, backside. It is a staff reading taken at a known elevation. It is the first staff reading taken after the setup of the instrument. Means okay, here I have station A, B, C, etc. Okay, here I have my benchmark. 100. Okay. Before I proceed forward, okay, first I should take the reading with respect to my benchmark. Okay, reading with respect to the benchmark. So what I will do, I will take the back side. After taking the back side, then I will continue in the forward direction. I will bisect A, it will be foresight, and if I see the station B, it is intermediate side, and if I shift my station at here, okay, and if I take reading backward means will be again back side. Okay. Back side, foresight, intermediate side, back side, again foresight, intermediate side. Next, we have foresight. It is the last staff reading taken denoting the shifting of the instrument. Okay. Intermediate side, it is the staff reading taken on point whose elevation is to be determined. Okay. All staff reading between backside and foresight are the intermediate side. Okay. Then change of point, okay, means you are shifting. This is my station A, here it is B, and it is C, and it is D. Initially, you have kept your instrument here. You have taken this side. Then, if you change if you move your instrument from station A to station D, means this will be CP1, or you can call TP1. Okay? Call it as P1. Okay? Change of point 1, and this will be change of this will be 0. This will be 1, like this. Then instruments of level. Okay, we will use level and leveling stop. Either it may be auto level or dumpy level. Okay, we have two types of levels here. So we will see one by one. Level and types of level. Dumpy level is there, tilting, whale level, and auto level. Okay, but these two are most important. We will use day to day, dumpy level and auto level. What is dumpy level? First, I will show you the picture. Yeah. This is your dumpy level. It looks like this. And this is your tripod, and here we will have some 3 screws. Okay, we will have some screws, and here you can see the bubble. Bubble will be there for centering purpose. Okay, to keep the line of sight horizontal. Okay. So dumpy level is a simple, compact, and stable instrument. Okay. The telescope is rigidly fixed to its support. Okay. Hence, it cannot be rotated about horizontal axis. Okay. Just remember what it is. Here, the telescope. Okay. The telescope will be rigidly fixed to the base. Fixed to its base, hence it cannot be rotated about the horizontal axis. This is your dumpy level. Tilting level, it is also known as IOP, means Indian Office Pattern. In this level, the telescope tilts about the horizontal axis, and hence it is called as tilting level. You know what is horizontal axis and vertical axis. Okay. This is your vertical axis, and this is your horizontal axis. If this is okay, if this is, instrument is rotating about the vertical axis, some instruments will rotate about the horizontal axis. Whale level, it is the essentially difference between whale level and other levels is that the telescope is carried by two vertical supports, okay, base supports. The telescope can be rotated, moved, or even rise in waves. Okay, can be moved in all the directions. And this one is important. Auto level, it is known as self aligning level. It is recently developed. Okay, nowadays what we are using, it is all about the outer level. Okay, you can call it as automatic level. The fundamental difference between outer level and other levels is that the leveling is not manual, okay, but it is leveled automatically. It is achieved by inclination composite compensation device. Okay. This is the outer level. Okay. Here we have some adjusting screws. This is used to focusing screw is there, and this is to move this telescope in horizontal directions. Okay. Next one is leveling staff. Okay. Leveling staff are the scales. Okay, the whatever scale we have used, 15 centimeter scale, 20 centimeter, sorry, 30 centimeter square, it is one of the scale. Okay, which we use in the field, on which the distance are marked. Okay, means there will be a scaling. This is 0. This is 1 meter, 2 meter, 3 meter, and 4 meter. Okay, like this. Next, leveling staffs are of two types: self-reading staff and target staff. Self-reading stuff. The self-reading stuff can be read directly by the level man looking through the telescope. Okay, the person who is taking the sight can directly read the readings present on the chart. Common type of self-reading staffs are ordinary staff. These are commonly used. Okay, and this is an ordinary staff. Uh, soft SOP is a telescopic staff. Okay, and this one is a folding staff. Okay, here we will having three stages. Okay, which can, it will be, means you can open it and you can close it like a tripod. Okay, which can be extended and which can be reduced. Okay? Like this also, here we can open the scale. Okay, this is when it is opened completely, and this is when up open. But the one thing is that if you opening this one, you should open it completely until it touches the surface. If you are opening this one, you should completely touch this surface. Where the pictures are not there, I will show you in the Google only. Okay, one length of this, the one length of the one length stuff is solid. Okay, and made of seasoned wood. Okay, but we are not using nowadays. We are not using any wooden stuff. We are using of aluminum stuff. Okay, and wooden stuff, it is how much 3 meter long and graduated in the same way as in the telescopic stuff. Folding, we can fold it like this also. Telescopic stuff. So in telescopic stuff, such as stuff arranged in a three lengths. Okay, initially I have shown 1, 2, and 3. Okay, placed one into another. It can be extended full length by full length. Okay, you should pull it and you should open it. The top portion is solid and the center box is hollow. Means these first, second, and third. Okay, the first two are hollow one, and the top one will be solid because these two should be hollow because the upper portion should be coincided. Okay? The top portion and the total length of the staff is how much? 4 meter. The staff graduated in a such a way that the smallest division is 5 mm. Okay, important one. What is the least count of your staff? It is 5 mm or 0.005. Okay. The reading will be taken up to 3 decimal. Just remember the reading. Whenever I am writing the numbers, you can observe I have written 0.000. Okay. The reading will be taken up to 3 decimal points. Okay. The least count is how much? 5 mm. The value is marked in meters, okay, and marked in red, okay, on left. Okay, on the scale it will be marked, and those decimeters are in black on the right. Okay, in right side and left side, the smallest are marked at the left hand side with the help of red color, and the decicentimeter in centimeters they are marked in the black color, that is on the right hand side. So you can see this is your staff. Okay, this is a folded one. Here you can see the stages. Okay, I will share the video. Okay, we come to know. Here this is first stage, second stage, third stage. Okay. This one is hello, and this one is, will be the solid one. So one thing I will do, the remaining I will take in the next class. Before going that one, I will show you some figures. Okay, here we can see it is mentioned 1.4, 1.5, 1.7, 1.6, 1.7, 1.8. Okay, okay. Here we can see 1, 1, 1. It indicates it is 1 meter. Okay. In the next scale, it will be 2, 2, 2, which indicates 2 meter. Okay. And you can see this gap. Okay. Here, if I take the highlighter, this is the big one. Okay. This gap. Okay. This is nothing but a 5 mm. Okay. 5 mm. This black line is also 5 mm. This black line it is 5 mm. This is how our ranging leveling stuff will be there. So when you are seeing from the telescope, means when you are seeing from the telescope, it will be like this one. Okay. So if it is bisecting at this point, therefore the reading will be 1. Okay. Point here we have 5, 1.5. Okay. Here we can see this is 0, 5. This is 1. Means this is 1, 2. Okay. Means it is half here, that is 25. 1.525 meter. Okay. If your shaft is at this point, okay, it will be 1 point. Here we have 1, so 1, 5. Okay. This is 1, 2, 3, 4, 5. This will be 5, 0, 10, 20, 30, 40, 50. You can go like this also. Okay. Suppose if your line of sight is at this position, okay, this will be 1.6, 10, 20, and 25. This is how we will take the reading. So in next class, I will explain about the staff, target the staff, okay, how to take the readings. Then we have different benchmarks, which I have said. Then adjustment, okay, then how to set up your auto level or dumpy level. Here we have is there how to use the screws. And classification of levels. Simple level is the differential level, high level, check level, profile leveling. Okay. So we will see according to the syllabus. Still, I need nearly 6 classes to complete your first unit because it is very lengthy. And here also we have some numericals. The rise and fall method is there, and the height of instrument method is there to determine the relative positions or radius level for different positions. So tomorrow is not possible. Sunday, Monday. Directly, I think the class will be on 15. So up to that, what to do? Just I will share some of the videos of the video links. Just go through it. If anybody having doubt with respect to compass or a plane table, then you can ask to comment your roll numbers and you can do the class.